Hey, welcome back everybody, and welcome to Module 8. Module 8, and I'll show you the book here we're going to be working out of, is about connecting algebra and geometry. And since we're going to be working with a lot of geometry, you're going to find that we're going to work with square roots a lot. And, well, the Pythagorean theorem, you probably remember that from middle school, is going to play a pretty big role in this unit or module. So I thought we'd begin the module with just reviewing radicals and doing a little bit more in-depth look at them than we took in the previous modules. So let's get started working on some of these. And I'm calling this 8.1. That won't correspond to the book really. So we're going to have 8.1, 1.1, 1.2, 1.3, and so on. And I'll make these videos kind of short, and I'm going to show you two ways to work with these things. Okay. All right. So what I've done again is I've kind of just made you notes here. So if you're writing down notes, then obviously work at your own pace. Pause the video as you need to. All right, so 8.1, I'm just calling this simplifying radicals. We're only going to work on the Math 1 level for right now with square roots. We're not going to get any more complicated than that. And here's a key property, and I've already taught you this in another module. So you kind of know this, but I wanted to go over it with you one more time in this videos before I start assigning work with this stuff. All right, so one of the key properties of square roots says this. If you're taking the square root of a product, that's what you're looking at right here, a times b, then it's okay to take this product and separate it into two different square roots, the square root of a times the square root of b. Okay, so, and that's a result of an exponent rule that you actually have learned before too, but I won't get into all that and make it more confusing. All right, so if we're using this property right here, okay, let's just take a look at this and I'll show you kind of how this would work. This would be, oh, I don't want to do that. This would be, we know that 50 is a product of more than two numbers actually, so, but it could be looked at as a product of 25 and 2. So I'm going to call it that because that's a true statement, 25, and we'll say times 2. And that property allows me to separate this into two square roots. That's the square root of 25 times the square root of 2. Okay, so what happens here is we know the square root of 25 is 5 because 5 squared is 25. 25 is a perfect square. All right, so we're going to say this can be written as 5 times the square root of 2, and you're going to find that they all omit that multiplication symbol, and they'll just write 5 times the square root of 2, and you'll hear me say 5 root 2. When I say 5 root 2, I'm saying square root of 2. Right, and I guess I kind of get lackadaisical with my language sometimes, but that's an example of doing it by the theorem here. But I've showed you other ways to work with these as well. If you remember back when we learned this the first time, we used a method called a factor tree, and I'm gonna go over this one really quick with you, and we're gonna take 50. You know what we had, 50. And work with it in another way. So if we take 50, this is just review, and I'm looking for ways to factor 50, but the way I taught you in the factor tree method was start with the smallest prime number that will divide 50 and use it until it no longer works. So 50 can be divided by 2, and we get 25. Then I said, keep using that number until it no longer works. Well, it no longer works. So we switch to the next smallest prime, which will divide 50, which is 5. Well, I mean, divide 25 in this case. And that's 5 times 5. So we'll find, every time we find a pair, we find a perfect square. This comes out. The 2 stays in. So everything circled comes out, and numbers that we don't circle stay inside. In a next example, I've got another one with a little bit larger of a number. Okay, so let me get rid of this with my little bomb feature. Look at this. Boom. Nice, huh? Okay, so that's gone. Let's come down here and work on a different number before we call this thing a day here. Okay, so we're looking at, somebody says simplify the square root of 180. And, okay, so the way I want to work on this one, I'm going to go straight to my factor tree because I feel like most people would do it that way. It's a popular method. Some might argue that it's not the best method. Whatever they say, that's up to them. But I've found through teaching through the years that people will use this method, and they remember how to do it. Okay, so we're going to throw this square root of 180 in here and use the same method we just used. And now we're going to take this 180 and we're going to use our factoring technique. Now it's even, and since it's even, we know the first prime we need is 2, because every even is divisible by 2, and we get 90. And 2 works again. Remember, use it till it no longer works, and we get 45. 2 doesn't work anymore. Now, some people would be tempted here to say 5, but it turns out 3 will work. So you always go to your next smallest prime. And 3 works, and that gives me a 15. 3 works again, and I get 3 times 5. Now we know we're done when the leaves of the tree, these are the leaves, are all prime. Okay, so this is done. Now we're going to circle our pairs. A pair of 2s and a pair of 3s this time. And the only thing not circled here is that 5, but he stays inside. So a 2 comes out, a 3 comes out to join it, 5 stays in. So this becomes 6 root 5. All right? And that is how we would simplify the square root of 180. So 6 root 5. Let me type that in here. And that is equal to 6 root 5. Okay, now that means that it was 36 times 5, but I didn't see it that way. See, if I just, anytime you see a perfect square factor right away, you can take the square root by that property, but sometimes you just don't see them and the factor tree kind of clears it up. I hope this video was helpful for you, and I'll see you in the next video.